guys, welcome back. I'm going to discuss today important Viva questions that are required for your chemistry class 12th CBSE Board Practical Exam. So go prepared with all these questions. Hopefully nothing beyond this will be asked. So I'll be explaining to you Viva questions related to all the experiments. Let us go ahead. Now, some important questions. What are the different types of titrations done in 11th and 12th? 11th standard, we were doing acid-base titrations, the neutralization reactions. This year, we are doing redox titrations, and most of the titrations involve KMnO4, which is having oxidation state of manganese +7, and in acidic medium, it changes to manganese +2. So it undergoes reduction, hence acting as a oxidizing agent. So we have redox titrations where KMnO4 acts as an oxidizing agent. What is the standard solution? It is the one that has a known strength or concentration. That means a solution whose concentration is known is called as standard solution. It can be 1 molar, 2 molar, 0.5 molar, anything. If we know the concentration of a solution, we are going to call it a standard solution. And standard solutions of primary standards are prepared by direct weighing. So you can be asked a question, what is the difference between a primary standard and a secondary standard? So primary standard is that which can be prepared by direct weighing because it doesn't have impurities. It is obtained in pure form. Oxalic acid and Mohr salt out of the ones that we've done are primary standards, and a secondary standard is the one whose standard solution cannot be prepared by direct weighing. Why? Because it has certain impurities. Example is KMnO4. Why KMnO4 is not regarded as a primary standard? Because it is difficult to obtain it in its pure state. It generally contains an impurity of MnO2. Why is Mohr salt preferred as a primary standard in volumetric analysis over ferrous sulfate? Very important. Why is ferrous sulfate? Because Mohr salt is still in ferrous sulfate dot ammonium sulfate, right? Dot 6H2O. So why don't, and the active component in Mohr salt is basically ferrous. It is ferrous that changes to ferric. So why are we using ferrous sulfate in the form of Mohr salt and not pure ferrous sulfate for this titration? This is due to the fact that Mohr salt is stable, does not readily oxidize in the presence of air, whereas ferrous sulfate is easily oxidizable to ferric sulfate through oxidation. So Mohr salt is a more stable substance, hence it is used as a primary standard. Why is dilute sulfuric acid suitable for permanganate titrations? Because KMnO4 acts as a good oxidizing agent in acidic medium. If acid is not used, KMnO4 may be reduced to MnO2. And a very, very important indication for you, if supposing, and this happens every time during practical exams, if supposing while doing your titration, your endpoint comes from colorless, endpoint should be colorless to pink. But if you find that the solution is becoming colorless to light brown, brownish color, yellowish brown in color, that means you have missed adding sulfuric acid. And since you've missed adding sulfuric acid, KMnO4 in a neutral medium tends to convert to MnO2. That means MnO2 must have been formed, which is brown in color. Clear? So you must immediately discard that particular reading and take a fresh sample, add dilute sulfuric acid and take your reading again. The next is this is a very important Viva question. Can we use nitric acid or hydrochloric acid instead of sulfuric acid to create acidic medium? So nitric acid or hydrochloric acid cannot be used to create acidic medium. Why? Nitric acid itself is an oxidizing agent. Now, what is the overall titration about? You have KMnO4, you have, let us say, ferrous sulfate in the form of Mohr salt, and then you add sulfuric acid. The net outcome that you want is this ferrous should convert to ferric, and this permanganate should convert to Mn2+. So basically, this KMnO4 used will depend upon the amount of ferrous present, right? But if instead of sulfuric acid, you are using nitric acid itself is a strong oxidizing agent. Now, we are using KMnO4 as an oxidizing agent, but if nitric acid is used, nitric acid also is a strong oxidizing agent. You can imagine it also will help KMnO4 to oxidize some ferrous to ferric. So basically, we are having two oxidizing agents, KMnO4 as well as nitric acid. So the titer value, if I speak technically, the titer value will decrease. Why? Because the amount of KMnO4 that is going to get used is going to decrease because nitric acid is helping KMnO4 to do the same job. So using nitric acid, the titer value will decrease. Similarly, why can't we use HCl? Because HCl itself is oxidizable to chlorine. So KMnO4 along with oxidizing ferrous ion to ferric will also get used up to oxidize HCl to chlorine, which means the titer value will increase and all that volume of KMnO4 used is not going in oxidizing ferrous sulfate or oxalic acid. Instead, some extra amount is being used to oxidize HCl to chlorine, which we do not want. So it is safest and best to use sulfuric acid, right? Now, why is dilute sulfuric acid while preparing a standard solution of ferrous ammonium sulfate? This is to prevent hydrolysis. Excessive heating is also avoided when dissolving the salt mixture in water. Why? Otherwise, ferrous can also change to ferric. Ferrous sulfate is very easily oxidizable to ferric sulfate. Now, how will you prepare 100 ml 0.1 molar standard solution of ferrous sulfate solution? What are you going to do? Molarity is equal to W upon molecular weight into VmL into 1000. This is the formula. So your question is 0.1 molar. You have to find the weight to be used. The molar mass of Mohr sulfate is 392. You want to make 100 ml. And to convert ml to liter, we are going to put 1000. When you cancel this off, you get 10. So W is going to be 392 upon 10. So that means you're going to require 3.92 gram of ferrous sulfate. And again, I spoke about this in my last video also. I'm repeating 3.292 gram is not to be added to 100 ml water. But 3.92 gram is to be dissolved in water and the total volume should be made to 100 ml. We don't add 100 ml water, but we make the total volume to 100. I hope this is clear because when you study the definition of molarity, you have studied it as the number of moles of solute present per liter of solution. It's not just a solvent, it's per liter of solution. Right? Now, which of the following is an oxidizing agent and which is a reducing agent in the reaction of KMnO4 and ferrous sulfate? Oxidizing agent is KMnO4, reducing agent is ferrous sulfate because ferrous itself undergoes oxidation and KMnO4 undergoes reduction. Which indicator is used in permanganate titrations? No indicator is used because KMnO4 acts as a self-indicator. What is an indicator? Indicator is basically something which changes its color along with change in pH. Fine. So KMnO4 itself is deep purplish pink in color, and when it changes to Mn2 plus, it becomes colorless. This is pink to colorless. So this itself can act as a self-indicator. In KMnO4 titrations, the brown PPT is occasionally observed. Why is this so? So I told you earlier also, if you miss on adding dilute sulfuric acid or if dilute sulfuric acid is not enough, then there will be formation of MnO2 because KMnO4 in neutral medium changes to MnO2, which is brown in color. So this is the reason for this brown PPT. Why is a burette with pinch cork regulator not used for permanganate titrations? Pinch cork regulators are those like if you have old burettes in your lab, they have a material which is corroded by KMnO4. They are made up of rubber. So rubber is corroded by KMnO4. So we avoid using these burettes. Why do we heat oxalic acid solution containing sulfuric acid up to this in the permanganate titration? Now, children, you have done two titrations. You've done a KMnO4 versus Mohr salt titration, and then you have done KMnO4 versus oxalic acid titration. And oxalic acid, you know, is a covalent compound. Oxalic acid is a covalent compound, and Mohr salt is an ionic compound. Mohr salt is ionic, this is covalent. Ionic means in aqueous solution, it's already separated into ions. Already free ions are present, so it's easy for the reactants to react. Whereas in case of oxalic acid, we have covalent bonds, and covalent bonds need more energy to break. So for oxalic acid, we have to heat the titration flask to 50 to 60 degree. Now, how much temperature is 50 to 60 degree? It just feels enough hot on the back of your palm. Clear? That's one test we use. You don't have to boil it. It is good hot temperature. And in case you are very slow in doing your titrations and you're talking in between and the solution gets cold, you must reheat it. The titration has to be done at 50 to 60 degree temperature only, right? Why should a titration flask not be rinsed? Very, very important question. I posted a separate video on this. Titration flask should not be rinsed, children. Pipette and burette is to be rinsed. Is to be rinsed, but titration flask is not to be rinsed. Not to be rinsed, only washed with water. After every reading, you simply discard the material. You rinse it with water, just wash it with water and do the next reading. Why? Because let us suppose you are pipetting out. I have a proper video on this. I'll be sharing the link, right? You can check that, because if I start explaining here in detail, it'll become very long. I'll share that link. Now, why must the burette and pipette be rinsed with the solution with which they are filled? So, burette, let us suppose, is washed with water. It has some droplets of water already, and you're pouring into it, let us say 100 ml, let us say 50 ml of 0.1 molar solution you are pouring into this. Now, if already there are droplets of water, what will happen? The solution will become dilute. The new concentration will become, let us say the new volume becomes 50.5 because 0.5 ml of droplets were already there. The new molarity is going to be different. So if water is already there inside, when you pour certain solution, it is going to dilute that solution. So burette and pipette should be already rinsed with the solution which is finally to be poured into them in order to avoid this. Now, why is it customary to read the lower meniscus in colorless solutions? Now, just for your information, I'm telling you, when you were doing these experiments in +1, we had sodium hydroxide, HCl, sodium carbonate, these kind of solutions, all colorless solutions. So for colorless solutions, always the lower meniscus is to be noted while taking the readings. Lower meniscus means this level of the liquid has to be taken as the reading, right? But if the solution is colored, if the solution is colored, let us say we are talking about our 12th standard work, colored solutions. So colored solutions, the lower meniscus is difficult to read, so the upper meniscus is taken. We always take the reading from here for colored solutions. Colored solutions, upper meniscus is noted, whereas for colorless solutions, lower meniscus is noted.